Hello, fifth graders. This is Mrs. Marcos, and today we are going to be learning about powers and exponents. This is lesson 3 in chapter 2 of your math book, and this is on page 93. So please make sure you're on the right page in your math book. And notice that our essential question is still the same. Our essential question is going to be the same for the entire chapter. And it's what strategies can be used to multiply whole numbers? What strategies can be used to multiply whole numbers? And once again, this is going to be on page 93 in your math book. So if we start at the top, it says a product of identical factors can be written using an exponent and a base. The base is the number used as a factor. The exponent indicates how many times the base is used as a factor. So that's a lot of words there, a lot of math words. So let's just remind ourselves what some of these words mean, and then maybe we'll read that one more time. So product, that's the answer to a multiplication problem. Identical factors, that means the exact same factor. So for instance, if you have 8 times 8, of course, that's equal to 64. But 8 and 8, those would be identical factors. So in this case, 8 and 8 don't happen to be prime. So we probably won't be using those as identical factors in this lesson, but still, identical factors are the exact same numbers multiplied together. And here's some particular vocabulary for this chapter: exponent and base. And those, notice, those are highlighted in yellow. Those are particular vocab words, and we'll talk about those more in this lesson. So let's do the first example. So math in my world, example 1. Says the number of calories in 6 pancakes can be written as 10 to the 3rd power. Write 10 to the 3rd power as a product of the same factor, and then find the value. So this is probably new notation to most of you, and it doesn't mean the same thing as 10 times 3. It definitely does not. Here's what it means down here if you look further in your example. It means 10 times 10 times 10. So 10, as you can see here in red, 10 is what we call your base, because that's the number that is being multiplied together. 3, which is in blue, 3 is called your exponent. It's it's kind of a smaller number up here floating in the air. That is your exponent. So 10 is the base. That's the number being multiplied together. And you know how many times to multiply 10 by itself because of this number here, the blue number, which we call your exponent. So in this case, because your exponent is 3, you're going to multiply 10 by itself 3 times, which is not the same thing as 30, as you well know. So if you do 10 times 10 times 10, first of all, I'm going to multiply 10 times 10, which I'm going to get 100. And then if I do 100 times 10, think to yourself in your head, what might you get? You're going to get 1,000. So definitely not the same as 10 times 3. Definitely not the same. Very big difference. So this is pronounced up here, back up in our example, it's pronounced 10 to the 3rd power. So 6 pancakes have 1,000 calories. 1,000 calories. All right, so let's keep going. I know these are new words and new notation for you, but let's use it a little bit more and it'll become more familiar. So here we are at the bottom of page 93. We just finished example 1, and it says numbers expressed using exponents are called powers. There's another vocabulary word, it's highlighted in yellow. Numbers raised to the second or third power have special names. So if you look over here at the chart, it'll show you what those special names are. So 2, this notation here is pronounced 2 to the 5th power. This notation here, the 3 as the base, the 2 as the exponent, here's how you pronounce it if you were saying it out loud. 3 to the 2nd power, or you can pronounce it as 3 squared. We just did this one in example 1, you've got 10 as your base, the larger number. And then you've got this little floating number up here. That's what we call the exponent. It's pronounced 10 to the 3rd power or 10 cubed. So you'll get more familiar with this notation and how to say it in word form as we do these problems in class. So make sure that you have those blanks filled in, and let's go ahead and turn the page to page 94. All right, example 2 is on page 94. And I'll just write the page number at the top. There you go, we're on page 94 in your book. So here's an example of a problem you might see when working with exponents, bases, and powers. So it will say, write 3 times 3 times 3 times 3 using an exponent. So that means, here's what we have to do. We have to write 3, because that's our base. That's the number being multiplied a certain number of times. And we have to use an exponent. So remember, the exponent is the little number floating kind of up and to the right of our base, which in this case is 3, because that's the number being multiplied together. So let's see if we can fill in some blanks here. So the base is going to be 3. Since 3 is used as a factor, let's see, 1, 2, 3, 4 times, the exponent is 4. So if we write that as a power, 3 times 3 times 3 times 3 should look like this, 3 to the 4th power. No, it's not 34. No, it's not 3 times 4. Those are not the same. This is pronounced 3 to the 4th power. And here's how you would find the value. You would say 3 times 3 is 9. 9 times 3 is 27. And then 27 times 3, what's 27 times 3? So that is going to be 81. So definitely not the same as 34, not the same as 3 times 4. So you're actually doing repeated multiplication. And remember back on the previous page, we talked about products of identical factors. So in this case, 3 times 3 times 3 times 3. So 81, or 3 to the 4th power, that would be a product of identical factors, because 3, all these 3's that you see that you're multiplying together, those are identical factors. They're the same thing, the same factor. All right, make sure you have those blanks filled in. That's example 2. Let's move on to example 3. So it says, write the prime factorization of 72 using exponents. And here we have something familiar. Here's a factor tree. You guys practice these in lesson 1. So we just have to complete the factor tree. So we start with our number, and it looks like we have to figure out 9 times what will give us 72. So hopefully you were thinking in your head, and that should be 8. So 9 is not prime, so we have to continue to factor that. 8 is not prime, we have to continue to factor that. So we have to think of 2 numbers that when we multiply them together, we get 9. And remember, we can't use the number 1 in a factor tree because 1 is not a prime number. So let's see, other things I can think of that I can multiply together to get me 9. I would do 3 and 3. For 8, let's see, I can't use 1 and 8 because 1 is not prime, but I can use 2 and 4. I can do that. So 3 is prime. So I just bring that down to the next level. 3 is prime. 2 is also prime. 4 is not. So I have to continue to break that down. And 2 numbers that I can multiply together to give me 4 are 2 and 2. Just like that. Remember, I can't use 1 in a factor tree. So it looks like I've got all of my prime numbers. We know that 2 is the only even prime number. 3 is a prime number because it only has factors of 1 and 3. And then so if we put our factors in order from least to greatest, like we did in lesson 1, then we would put our 2's first because those are smaller than 3. And then we would put our 3's down. Okay. So there's our prime factorization. But now that we know a little bit about exponents, what we can do is we can write our answer in a different way. So it says write the products of identical factors using exponents. So since I have, let's see, 1, 2, 3 2's, 2 is my base. That's the number being multiplied together, right? Those are the identical factors, the 2's. And how many times am I multiplying 2 by itself? I'm multiplying it by itself 3 times. So I have 2 as my base, 3 is an exponent. And then I have to multiply that times 3. I have, let's see, 3 is my base. I'm multiplying it by itself 2 times. So 2 is going to be my exponent. So basically what I do is I take my prime factorization all stretched out kind of the long way like this in step 2. And then I can write it a little bit in a little bit shorter way using bases and exponents. I write it, it would sound like this if I said it out loud. 2 to the 3rd power times 3 to the 2nd power. So the prime factorization of, here was our original directions, the prime factorization of 72 using exponents. So that's what we have. If we follow the steps, it's just going to be 2 to the 3rd power times 3 to the 2nd power. There's our prime factorization using exponents. What's this little guy say? It says, explain how a factor tree helps you to write a prime factorization of a number using exponents. I think it gives you a good structure to work with, because you know when you get to the bottom of your factor tree, you should have all prime numbers. That means numbers that only have 2 factors. All right, for your guided practice, it says write 4 times 4 times 4 times 4 using an exponent. So that means we have to use one of those little floating numbers. So you can see that 4 is our base because that's the identical factor that we're multiplying together a certain number of times. And our exponent here should represent the number of times we are multiplying our base. So it should look like this, 4. So the base is 4. Since 4 is used as a factor, that means you're multiplying it together. Since 4 is used as a factor 4 times, the exponent is also 4. So just like I showed you right up here, 4 times 4 times 4 times 4 can be written as 4 to the 4th power. So if you completed, I believe it was page 73, which was the Are You Ready for Chapter 2, we were reminded that multiplication is basically repeated addition. So you can rewrite repeated addition as multiplication. It's kind of a little shorter, a little more efficient. So basically what you're doing here with bases and exponents, so numbers that can be written as powers, you're basically writing repeated multiplication in a little shorter way. So kind of like a different, more efficient format. So please make sure that you have these examples completed, make sure that you have them filled out, and then also the guided practice here for page 94. And then you have some independent practice problems on page 95, similar to what you saw in your examples and also the guided practice.